This presentation is about composite structures and cambering. The objective is to give you guys some information about what is composite construction and a different element that is cambering. Well, the information is provided according with common design and construction practice and is adequate for buildings that are 12 stories or less. We'll have some more information here in aspect related to general knowledge of structural steel, knowledge of the different details of composite steel construction and the components that are used and how these composite structures are installed. The understanding of the impact of composite in the steel construction regarding schedule, cost, sequence, etc. And inside of the process to create camber and why camber is used and situations where it's convenient to have beams that are camber or not, and how using camber beams may affect a project. As we already studied, structural steel have a lot of benefits. According with the American Institute of Steel Construction, some of the benefits related to steel are the following. The time of the frame construction will be shorter and is possible to build in all seasons because the material will arrive with the shop ready to be installed. It will be faster and there are less mistakes because the material already came with a certified quality. Steel is convenient because can have long spans as big as any other material and better and cheaper than many other materials. Well, at the end, steel will be more flexible. Steel also is easy to modify and to reinforce. When we have a building made out of concrete, it will be difficult to think that this building now will be 5 stories higher and we need to reinforce the columns. With steel, that is perfectly possible. Well, it's possible to make changes and use the facility for after many modifications. Steel also is lightweight in comparison with other materials because even when steel is heavy by itself, the quantity of material that is used is smaller, therefore is at the end became very lightweight. Also is durable, is long-lasting, and steel is completely recyclable. There are some unique aspects of steel construction that we need to understand. First, different to other materials, steel is fabricated off-site. And even the perforations in the steel, the joints can be made outside of the place and everything will be put together like a puzzle on-site. On-site erections, therefore, is very fast, can be very well organized, and can be done in a very short time. That gives to the use steel the use of steel like some schedules advantage because we know exactly what will happen. And the coordination of all parties obviously is essential in order to have the material built in the fastest way. When we build with steel, we can have a composite construction. Composite construction doesn't mean a particular material together. It can be many materials that are composite and create a new type of construction. Composite first can be a material that is composite by itself, like some kind of plastics and some kind of fiberglass. Also, it can be a type of construction that is made using 2 or more materials. In this particular class, our composite construction relates to the use of steel and concrete together. And this is mostly done for floor systems. When we have a floor made out of, columns and beams made out of steel, it will be not easy to think that we will have a frame that is provisional, made, for example, out of wood, to support a concrete that after will dry and after will be part of one unique system. It will be easier to use a composite steel deck. This is a steel deck with concrete in the top. And in order to make this more resistant, it's possible to use weld fabric and shear connectors. This kind of construction is very convenient because it's very fast and is very well adapted when we have steel columns and steel beams. A steel beam is made composite by using shear connectors. Composite metal deckings and concrete is much stronger and tough than the base beam alone. The idea is very simple. We will have steel columns and beams, and the floor will be out of concrete, made out of concrete, but the material will be a composite one because the frame that will support that concrete during the time that it needs to dry and fragment will be made out of steel. Well, this will be the typical steel that a piece of concrete needs in the inferior part, I mean in the bottom part. Normally when we have a frame, let me go back 1 second and show it like in a drawing. Normally when we have, for example, a floor made out of concrete, this is the concrete, this is the thickness of that frame. And usually we draw the concrete with triangles, small circles, or almost circular elements, and also points. That is the expression that we use in order to say this material is concrete. But the concrete doesn't work by itself. The concrete will need other materials. Well, usually what we do is that we have steel. Normally there are rebars, or there are pieces of steel, if we look in the other direction, that are cut like this and are like rebars, or we have something like a frame made out of steel. And that frame will be just located in the top area and in the bottom area. Here in the bottom, we have this steel, and in the top, we have this steel. Well, what we will do now is that we will just substitute the steel that is in the bottom by this steel frame that we are looking here, that is a piece of steel that has been like with rollers is changed and have this particular form. And in order to make this to work better, we need to connect this steel with the concrete while using these elements here that you can look in the photo. We will have what is called a shear connectors. And many times in the superior part, in the top part, we will have also more steel. Well, that make a frame very strong. And it's like you put the steel together with the concrete, like in a machine, and you blend them together and become one unique material. Well, the material will have the good properties of the steel and the good properties of the concrete. What will be a good property of the concrete? That work very well in compression. And the steel is flexible and work well in compression and also in tension. And that will happen with our particular element. Let me go back here and clean everything. Okay, and continues with the next slides. Well, as you can look here, we have this element made out of steel, and it has some like texture in order to allow the steel to really attach well to it. And there are the shear connector, and in the top there is like a small steel frame that will allow this material to act together. The floor system will be tough, lighter, and less expensive. Well, the advantage of this composite construction is that we can connect the concrete to the steel beams and have advantages such as reduce structural steel frame cost. The weight of the structural steel frame may be decreased. It may reduce the foundation cost because if the weight of the construction is lower, also the foundation that is supporting everything will have a lower cost. The live load deflections may be better. The beams may be shallow and may be used to reduce the building height. The increased span lengths can be possible, and the floor probably will be much stronger. The disadvantage of this composite is that we have an additional personnel that is need to locate those steel connectors and install them, and that can become expensive because it need to be welded, and the concrete flat work contractor also need to have experience and be able to do a good job. Let's go to the next. Metal decking. Metal decking is this composite material that is necessary to make this a composite structure, and normally is a kind of a steel element that is just make with rollers. There is just making that form and allow us to create several profiles and also thickness. The decking is like some kind of deformed reef, and we can look here that these deformations in the ribs are made to create a stronger bond between the concrete and the bending material. After this is made, the concrete is located in the superior part, and there are several types of composite deckings, and we can have deckings with ribs that are made by dovetail or flute patterns like the one that we are looking here. We can have decking with welded fire fabric in the superior part. We can have decking with steel rods that are welded across the ribs, etc., etc. The installation of this decking is a process that is a little bit complicated. It's necessary first to place the material in the predetermined points with a very strict sequence. After, the material need to be installed by the steel erection contractor or to a separate decking contractor. Well, there are many standards that will control how this decking is made, and it's necessary to be very careful that all the placement of this material is made adequate in the most adequate way. Also, there is the obligation to have some guard trail systems, and make sure to eliminate the possibility that people can fall down. Some restraint systems to falls, and safety net systems. Thereafter, is necessary to weld the deck to the beams, and that is normally made using like weldings that have welding crew that have the possibility to cover like 2,700 square feet to 3,860 square feet per day, depending the thickness of that material, or what is called the gauge of the material. It's also possible, a part of welding is possible to have some tools that will be able to locate some elements, to just try to use like elements similar to nails that will be able to attach the two materials and faster them. When the steel element is already put together and weld or attached to the beams, we need to locate the shear connectors. Those connectors will be in the places where are beams under the roof in order to allow to bring shear capabilities and steel in the middle and top part of the concrete. They are normally called studs or shear studs. There are many types, size, materials, grades. Some of them can be heated like the one that we are using, that is the most common. And some others will be similar to C-channels. And what happens is that the welding process can change, but normally what will happen is that the tip of the shear connector may be placed in a ceramic ferrule like an arc shell, and we are allowed to connect two materials to welding. Well, this will be a strong bond between the steel beam and the concrete floor slab that will be poured in the top of the metal decking. This bond will allow the concrete to work with the steel beams and reduce the load of the deflections. Well, the shear connectors are installed after the decking is in the place, and there is normally a specialist to do this particular job, and there are a special weld equipment that is required to do this particular connection, and usually a person will do about 1,000 connections per day. The installation of the shear connectors will be located in the particular plans. We have here, for example, that we have a beam W6 by 26, and in the places where those beams are located, we will have a particular element that will be located, that is, for example, 3/4 elements that will be located there, and we have even the distance and all the information that is necessary to understand how that will work. The spacing sometimes is not uniform, and that will be indicated in the plan. And the spacing of the shear connector is an important part of the design, because it's necessary to understand how much steel will be needed to create that connection, and there are minimum spacings that need to be located in order to resist the compressive forces. Well, the electrical arc process is normally used in order to weld the studs. And we will learn a little bit more about this process later on, but the idea is that like a very high intensity of electricity will create like a fire product of an arc, and will start melting the steel and connect them. Well, the metal will solidify and the weld will be complete. Therefore, the ferrules, like some elements that are used in order to product of this process, it will be eliminated. Well, later on, when all the steel is already there, we will just install the concrete in the top of the material. Usually the concrete will arrive, and from the truck, like it will be poured inside of the building, and normally there are some pumps that will be able to just pull that concrete from the trucks and put inside of the element. Well, it's possible to build a concrete slab of 10,000 or 15,000 square feet in a day, depending how thick is the slab and the crew size. Well, the concrete is put into place, and the crew will start to flat that concrete and make a flat surface. Usually there are pieces of wood that are located in order to make sure that the surface is perfectly flat. And it's important to avoid a bond failure between a part that is hard of concrete and the other one that is new concrete that we will locate. It will be better to put all the slab together. Well, the day that a slab is poor is a day of very hard work and a high presence of crew personnel in order to make sure that everything works perfectly. Well, we can look here that the concrete will cover the superior part, I mean the top of this element, and will cover completely the studs. And after they make sure that dry according with a cure process. The shear connectors using this kind of composite materials require inspections. Well, usually what happens is that the installer will locate all the shear connectors and will have everything ready, and before pouring the concrete, somebody from the local building authorities will come and make sure that everything works very well. Usually there are very strict and things need to be made exactly as the approved plans. Most of the issues that can happen during this kind of installation is that we can have some kind of moisture in the deck, what is not convenient. Also, when the temperature is less than 0 degrees Fahrenheit, it will not work well. Well, we can look here, for example, that a torch is used in order to remove the snow to be able to install those elements. Well, the required quality control and procedures are several. First, the pre-production testing is made in order to make sure that the stud installer are at the beginning of the work shift and include all the steps like making sure that they weld to sample stud and they work well, to inspect for flash, to perform a bending test to make sure that the elements are not bending, and the equipment settings are all recorded. Well, the stud installer will perform a visual fabrication inspection as the studs are installed. Other important reviews and testings are necessary if the visual inspection has some problems. Well, something important is the cost of this composite construction. When it's used in an appropriate way, usually this type of construction will be less than non-composite construction. Well, composite construction can be cheaper. The US national average for installation cost of shear stud range from $115 to $172 for every connector. A second process that we'll be studying in this class is called cambering. That is a completely different element. Cambering is a process that is used to create an intentional curvature, like a very small curvature in a beam. It's a slight curvature that will allow us to get some advantage. Well, the idea here is that we will have a percentage of dead load deflection. When we put weight in the top of the material, because we install, for example, the deck with the concrete, well, we will always have some kind of deflection and the beams will always deflect. Well, the idea is the cambering will compensate this kind of deflection. Let me explain this with a graph. Imagine that we have a beam that is like this. And this is an I-beam, like the ones that we are looking over there. And imagine that in the top of this beam, we put a composite deck that will be made also out of steel. Let me change color here. A composite deck like this. In the top of this composite deck, in some places, sorry, we'll have those shear elements. And after we will have like more steel in the superior part. We will put concrete in all this material, concrete here in the top, And obviously, this material will have a weight, and that weight will tend to create some kind of bending in the structure, and bending, obviously, in the steel that is supporting this material. Well, the steel beam will start to also bend a little bit and became like semicircular. Well, if I exaggerate, what will happen is that the beam will be like that, you see? Will just bend in this way. Well, what we will do, well, we will bend a little bit, this is exaggerate the material, the beam, and when we put the weight in the top, it will have the original form. It will become like straight. The idea is to provoke, before the installation of the floor system, to provoke some kind of slight curvature in the beams. Like this, when we put the loads, the beam became straight again. That is the idea of the camber. And that can be very, very convenient in some cases. Well, we can look here, for example, we have a beam, we have the shear connectors in the superior part. Look, this kind of beam have a union with the column that is here, okay? Let me go back and draw this one here. As you can look here, there is a union, what is called a connection. This is a simple connection because only the central area, this area here, is connected. Okay, this is an I-beam like this one, and the only part that is connected is the web. This part here, the web, is the one that is connected. The top flange and inferior flange are not connected. This is a simple connection, something that we will study later on. Well, in the beam, we have all these elements that we already spoke about. We put the concrete, and we put the concrete in the top, the beam will start to bend, and before the concrete is dry, the idea is that the beam became like straight. Well, the support beam will deflect into the load of the concrete when it's being placed, and the deflection can be exaggerated in a composite floor system in order to have achieved this straight element. Well, the camber beam will allow us to do that kind of deflection. Let me clear everything here. If we don't have the cambering, what can happen, and this is the advantage of the cambering, is that the beam will deflect, and in order to cover the shear connectors, we need to put more concrete in the center. See the difference in the one before? The concrete is straight, we don't use so much concrete. Here we use more. Let me go back. Here we use more because we need to have a separation, a minimal separation between the concrete and the shear connectors. And that minimum separation will happen in the string area. In the center, you will have more of the minimum. Well, that will be more expensive. It also will be heavier. Well, the concrete use as a volume will be 10 or 15% more if the floor has a constant, if the floor is in a constant thickness. Well, that will be very convenient. The disadvantage of the cambering, obviously, is that we need to limit according with the function of the place due to the complexity in detailing, fabrication, tilt up, etc., and connections. Well, when we have beams that are connected, like this one that are connected with a moment connection, look, the superior part, or the top part, sorry, here. Let me go back. And let me draw here. See, here, we'll take a thicker marker. Here is connected. Here is also connected. The two web is connected. In the center is connected. This is a moment connection. Well, this connection is not possible to use when we have cantilever beams, when we have, beams with this campering, because we want the beam to move a little bit here, you see, to have some deflection. Well, that is one of the disadvantages of this material. We will need to have simple framing connections, and normally those connections are used when we have loads that are not so heavy. The other problem is that we expect the camber to go straight, but sometimes that doesn't happen. It can happen that we need to put more concrete in the stream area because the beam didn't bend enough as it was necessary, as we wanted. Well, we can hear two examples where the cambering beam do not deflect as predicted when the wet concrete was there. Well, in the superior part, the studs are exposed because we put adequate quantity of concrete but didn't deflect. Well, now we need to put more concrete because the studs are there, and will happen what we have in the second one. We put more concrete than the one that is necessary because the material didn't deflect enough. Well, the top of the slab elevation is out of tolerance. Well, cambering is not the only way to do it. Alternative to cambering are the following. We can have a slab that have a different thickness. We want the floor to be obviously perfectly horizontal. Well, we need to put more concrete to just cover the area that the beam have a deflection. Second, we have oversized beams. We have beams that are stronger and oversized of what we really need just to eliminate the possibility that the material bend. It's normal that the material bend, but if we use something very heavy and oversized, it will not bend, but that will be also more expensive. And the other possibility is shoring. Shoring is locate some kind of columns that will be provisional and they will support the beam, that is number 3 here, and the beam will not bend. The concrete will be poor. The beam will not bend during the time that the concrete is drying, and when the concrete is dry, then we can take out the shoring. In order to use the concrete for the next floor as a base for the shoring, you need to have 75% strength, and that is several days that we need to wait in order to do so. Well, shoring may be used in lieu of cambering, and the construction documents must specify the use of shoring elements, and we can look here like we have some kind of wood piece that is just supporting the beam while the concrete is drying. Normally, advantage of use shoring is the light floor beams may be used, that camber don't need to be designed or fabricated because that's additional cost. We have a less beam deflection, and shoring can accommodate any kind of loading requirements because it's possible that we have loads that are higher than the ones that are specified, while shoring will be able to accommodate that very big loads during the time that the concrete is drying. Well, it's convenient to camber when we have girder beams, when we have filler beams, when we have a composite floor system, when members have an uniform cross sections, then it's convenient to use the camber. It's not convenient when we have cantilever beams, when we have crane beams, when we have moment connections, as I explained, when we have braced beams, because those braced beams will not deform so much. Here, for example, we have a bracing, and that bracing, this element will allow the material to stay in place. And when we have also spandrel beams, as you can look in the right figure. Beams with moment connections, as you can look here, are not convenient. Beams with no symmetrical loadings also are not convenient. Beams that are under 20 feet high, it's no matter to camber them because the deformation will not be that big because the beam is short. And beams that have end plate connections also will not be able to have the same deformation. Well, it's not convenient. Well, how the cambering is made, there are two ways. One is to just heat the material in some triangular areas, and after it's heat, the material will be placed upside down and will be supporting the bottom flange, and this flange will stand under the heat, and it will contract when it became cool. Well, this is induced in the opposite side of the beam when the element is becoming cooler. That is what will happen. The material will deflect. And we can look here that this beam was cambered and there are some elements there that is the effect that we have when the material was heat. The other possibility is the cold cambering. Here we'll have a machine that will create like a very strong force that will use to bend the material and create a camber. Normally, it's better to do all this process in a shop after the connections are fabricated. And well, it's necessary to mark those beams to make sure where they will be located. Also, there is a natural mill camber that is present when the material is received from the mill, and is typical in most beams. Camber usually 75% of the specified camber, and it can be very convenient because it's already made in the beam in the shop. And well, we can look here a plan, and in this particular plan we have a beam of 16 by 26, for example, and there is a cambering of 3/4 inches on it. Well, they are marked in the structural plans. You can look here, the camber in each one of them. Well, the beams will be installed. There is no additional tools. It will be installed like any other beam. And in the beam is written like a mark, like a standard practice of camber, and it's measured. For example, here 1 1/4 inches up. Well, also when the material is cheap, it will camber a little bit, because depending the weight that we are carrying the material will have like a small cambering. Well, it's important when the elements are shipped to make sure that are cambered in the adequate place. The cost of cambering obviously is important, but it needs to be compared with the cost of traditional concrete due to ponding, with the cost of using shores or additional provisional columns, and the cost of using a heavier section. Well, usually it will be done what is the cheaper. The cost of camber depends obviously of the other alternatives. Usually, studies has been made, like the one of Larson and Hussar in the 90s, and tell that the cost of cambering can save approximately 4% of the cost of the construction. The schedule also may change because we need time waiting for those elements that after they are fabricated, especially for that particular structure, the time that is necessary to camber it and deliver and erection will also change. All this presentation is part of the American Institute of Steel Construction. And there are some references. Thank you very much.